Alright gang, I'm going to make a little video and then you can take notes and ask the sub to pause at various spots if it takes a little while to copy down the graph or the work that I'm doing, etc. But if you understand everything that I explain on these problems, then you should be able to do the practice sheet that I'm giving. Okay? And I'll also post this to Canvas, so whatever you don't get right at this moment, you can watch again. Okay? So let's roll. So we want to be able to describe transformations in the coordinate plane using algebraic representations and words. This is a little bit of the information from the new HMH books in its section 1.3 if you wanted to put a number to it. Okay, let's roll here. Okay, we talked about a little bit, I mentioned rigid motion. So whenever we're doing transformations and it's described as a rigid motion transformation, it means that the new image actually has not changed its size, the shape, the angles, so there's a list of things that are preserved. So this is the list of the things that are preserved: distance, angle measures, betweenness, collinearity, parallelism. So you want to make sure you keep those in mind. Okay, so when we do a transformation, we're changing, the position, shapes, or size of the figure, and the numbers that you put in are considered the inputs, and of course the outputs are what comes out. The figure that's used is called the pre-image, and then whenever you're done, whenever you're done performing the transformation, that the result is considered the image. So we have a pre-image and an image. And we use certain notation. We tend to use just the regular letter for the pre-image, and then once we perform the transformation, that new dot, if you will, we usually use a prime. So A prime would be, that new location from A to A prime. Transformation is sometimes also considered a mapping, because you're mapping one point to another location. Coordinate notation is utilized, and so we'll look at that. And we'll look at, see if we want to look at this example. So the coordinate notation, it would show it like this. It would say xy is going to be transformed to x plus 2 comma x minus 3, which tells you just what you would think. You're going to add 2 to each of the x coordinates, and you're going to subtract 3 from each of the y coordinates. And you'll do that for each of the points that are part of your pre-image, and then that will create your image. So for example, if you had a point like 6, 5, then you would add 2 to the x coordinate, and so that would make 8, and then you would subtract 3 from the y coordinate, and then it would become 2. So that point 6, 5 would become 8, 2. So we'll look at several examples. Okay, so this is a picture of a triangle. So go ahead and get a particular sketch. Go ahead and get this sketch. So it's right at 4, 0 there, and it's right here at 0, 3, and right there at 0, 0. So A, B, C. And then we'll go ahead and perform this particular transformation. So what did we say we were going to do again? We were going to subtract 2. So let me go back to that one real quick. So actually for this one, let's go ahead and subtract 2 and subtract 4, so it would look like this. So let me write it. So x, y, we're going to subtract 2, and then we're going to subtract 4. So let's see what that would look like. So we would take each of these points. So we have 4, 0. So this is how we would kind of work it. So we'd have 4, 0 is going to become, and if we subtract 2 from that, then it would become 2. And then 0, we would subtract 4, so that would be 2, negative 4. So that point, so this is B, and then this point would become B prime. And then let's do point A. So right now A is considered 0, 3. So then we would say that's going to become A prime. So let's go ahead and take 2 away from 0. So that would be negative 2. And then 3 minus 4, so that would be negative 1. And then point C is just 0, 0. So then we'd want to do the same thing. We want to take away 2. So that would be negative 2. And then we want to take away 4 from the y-coordinate. So we got negative 4. Okay? So let's go ahead and plot those new points and see what they look like. So it would be 2, negative 4. So there's 2, 1, 2, 3, 4. So there's 2, negative 4. And that would be B prime. And then we want to go ahead and do the A prime, which is negative 2, negative 1. So that would be right here. So this would be A prime. And then we want to do the C prime, which is negative 2, negative 4. So negative 2, negative 4, 1, 2, 3, 4. So that would be C prime. And then we would connect those with the segments. And that would be our image. This is considered a translation. Whenever you just kind of add or subtract a number to the x's and the y's. Whoops. Considered a translation. Okay. Does that make sense so far? Okay. So those are just digital version of what we just did. Okay, now let's use this rule here and see how that changes things. So it looks like the x is going to remain the same and the y is going to be the opposite. See how that shows the transformation? So let's figure out what the points are here. So we got this point here is negative 1, 2. This point here is 1, 2, 3, 4. Negative 4, 2. And this point here is negative 4, 4. Okay, so you want to get a sketch of that. And then we're just going to, let's show a little work here. So let's say that r is negative 4, 4, and it's going to become r prime. So again, the x stays the same, so that'd be negative 4, but then the y-coordinate is going to be negative 4. And then s right now is negative 1, 2, and that's going to be s prime, and that's going to be negative 1, negative 2. And t right now is negative 4, 2, and it's going to become t prime, and that would be negative 4, and that would be a negative 2. Alright, let's plot those new points. So negative 4, negative 4, 1, 2, 3, 4, 1, 2. So this would be, pardon me, r prime. And then s prime, negative 1, negative 2. and t prime, -4, -2. 1, 2, 3, 4. Okay, so t prime, and connect those. Okay, so what does this look like? What does it look like it did? So you can think about that. This particular transformation will always reflect the object, the image I should say, over the y or over the x-axis. So notice the y's are just exactly the opposite. So again, if the x stays the same, then it just reflects it over the x-axis. Sound good? Okay, next one. So now this one, we are going to, no, JK, just did that one. There's all the work digitally of that one. Reflection across the x-axis. Okay, now let's try this one. It says you're going to keep the x the same, but then you're going to double the y. So let's go ahead and identify these points. So we've got j right now is -2, 2, and it's going to become j prime, and it's going to be -2, comma, and the y value is going to be twice whatever the y is, so it'll just be 4, and then we'll have L, which right now is -2, -1. That will become L prime, which is going to be -2 and then double whatever the y coordinate is, so -2. And then we got K, which is currently 2, -1. So that's going to become K prime, and that will be 2 and then the opposite. I'm sorry, multiplying the y by 2, so that would be -2. Alright, so let's plot those new ones. So we got -2, 4, so that would be here, and that is j prime. Then we got L prime, which is -2, -2, so that's this one. And then we got K prime, which is 2, -2, that's this one. Okay, connect those. And you can see when you do this, when you multiply the y value by a number like that that's bigger than 1, you just kind of vertically stretch the object. If you happen to multiply just the x coordinate by a number bigger than 1, then you would horizontally stretch it. So this particular one, you can see that would make sense if all your y values are getting doubled. You're vertically stretching it. Sound good? Hopefully. Okay. So, looks like that. And that is a vertical stretch by a factor of 2. Alright, now let's see what happens when we change the sign of the x and keep the y the same. So this time I have already written out the points. So let's see what our new points are going to be. So that means that A prime would become the opposite. So that would be -2, 1. And B prime would be the opposite. So -6, 2. So again, the y coordinate is staying the same. And then C prime is -4, 3. Alright, let's plot that, see what it looks like. Probably going to be a silly goose because it looks like I wrote it in the spot where it's going to be. Alright, so I got -2, 1. Yes, I did. Okay. A prime. And then I got -6, 2. 1, 2, 3, 4, 5, 6, 2. Aren't I smart? Put it in the bad spot. Okay, and then I got C prime, which is -4, 3. 1, 2, 3, 4. Oh, booger. Okay, so we'll connect those, and we'll still make it work. Okay. So this, if you look at it and compare, you might say, okay, what does this particular transformation do? When you change the x value and keep the y the same, you can just tell that your x is the opposite of where it was normally. You know, the x was over here and now it's over here. So what that does is that reflects the image over the y-axis. So again, that's just something you want to keep in mind. You want to memorize these particular special transformations. Okay. Now, what about rotating an object 180 degrees about the origin? What you'll want to equate is that that is the same thing as switching the x and switching the y. So that's just what actually rotates it, you know, about the origin. I should go either direction actually, since it's 180 if it's rotated about the origin, but it would go this way. Okay, so let's go ahead and plot that and see what it looks like. You know how if it's in the first quadrant, then it ends up in the third quadrant. That is if the whole object is in the first quadrant. So let's go ahead and figure out what those are. So I'll try not to put it in the third quadrant, so that's where my triangle is going to go. So switch both the x and the y. So -2, -1. B prime is -6, -2. C prime is -4, -3. So let me plot those. So let's plot them. So we got A prime there. Got B prime. 1, 2, 3, 4, 5, 6. I'm assuming you're all masters at plotting points. C prime. 1, 2, 3, 4. 1, 2, 3. Okay, so we got this here. So same, you know, it is a rigid transformation. It's the lengths of the segments are the same and everything. It's just been rotated 180 degrees. Sound good? Okay. All right. Okay, so as I mentioned, if you multiply the x's by some number bigger than 1, it's going to horizontally stretch them. So if we just multiply each of these x's by 2, we'll be able to visually see that that's what happens. So that's 4, 1. B prime, if we double that, it's going to be 12, 2. And C prime is going to be 8, 3. So I just made these up, and so I'm going to be in a little trouble, I can see, with one of these numbers. So 1, 2, 3, 4, 1, it's going to be A1, and then, or A prime, A1, oh boy, steak sauce, no, A prime, okay. And then B prime, 12, 2, so look at that, it's off my graph, it's 10, so it'd be over here. So it'd be like there, but 2 units to the right of that. So I'm going to say B prime, and then C prime is 8, 3. So that's 6, 8, so 3. So C prime. And then you would connect those, and I think you could still visualize that this particular image is horizontally stretched, because you're just multiplying those x's by 2 and you're leaving the y alone. So there are so many similarities between these transformations and the transformations of regular functions when you're horizontally stretching, vertically stretching, compressing, all these things. So this is great information to have down. Now, was that last example... Oh, now I lost it. Was that last example a rigid transformation, do you think? And I forgot to ask that or show that. So at the bottom here, I was asking if it is a rigid transformation, and what you'd have to do is just measure, you know, at least one of the if you had one corresponding set of segments that weren't the same length, then you would automatically say, oh, it must be a non-rigid transformation. So that one clearly had a segment that was longer than the other, and so that's all you would need to justify that it was a non-rigid transformation. And that would occur, whenever you're multiplying a number. You can translate, rotate, reflect, you're going to be fine. But as soon as you start multiplying a number like that to it, it's going to be bigger. Okay, what about this one? Do you think that it's going to be a rigid transformation? Multiplying each of these by 2? Just a guess. I hope you say no, so it wouldn't be. So all this would do is just multiply, obviously, both of them by 2, so that would be 4, 2. B prime, that'd be 12, 4, and then C prime would be 8, 6. And it makes your image, twice as big, and so you got 1, 2, 3, 4, 2, so A prime, B prime, of course 12 is off my little graph. That's alright, we'll pretend it's on there. B prime, and then 8, 6. Okay, and you can imagine then that the whole image is twice as big as it was. So all the lengths of the sides are twice as big. Okay. Alright, we're almost home. Let's see. Okay, rotating 90 degrees clockwise. Now that's another thing that you'll want to memorize. It's a particular transformation. So whenever we say 90 degrees clockwise, that is the same as switching your x's and y's as far as their location goes. And then whatever was the x-coordinate becomes a negative. So for example, this A21, the A prime would be 1, and then that would be negative 2. So that's 1, negative 2. So this is the A prime. And then it's probably a good idea to kind of do these a point at a time. And then B prime, so we would go switching, so we go 2, and then that would be negative 6. So 2, oh man, I'm way off my graph there too. Booger. Oh, actually not too bad. Okay, so that one is B prime. And then, so let's see, C prime is 3, negative 4. See that? How that one is the negative? So 3, negative 4. So 1, 2, 3, 1, 2, 3, 4. So that's C prime. Okay, so exact same shape, it's just been rotated 90 degrees. This is clockwise. Clockwise goes this way, right? Okay, if it is counterclockwise, the x's and y's switch, but instead of this one being negative, it's this one is the negative one. How are you going to keep that straight? Well, I think you can just sort of think about, where your coordinates would be. If you're going this way, then you know that whatever becomes that new x-coordinate needs to be negative, because how else would it be over in this particular quadrant? If it was, if it was positive, it wouldn't even be over there. So you can kind of think about that. The clockwise one, the x-coordinate was positive, so that's how you would get over in this particular quadrant. You'd have to have a positive x and then your negative y. So you can straight memorize it, or you can kind of figure it out each time. But you just know they switch, and then one of them's negative, and so you can figure it out. All right, so this one A prime, they switch, so that's going to be, and again, that would be negative 1, 2. So that's negative 1, 2, and that's A prime. And then B prime, that would be negative 2, 6. Negative 2, 1, 2, 3, 4, 5, 6. So that's B prime. And then C prime is negative 3, positive 4. 1, 2, 3, 1, 2, 3, 4. So C prime. Okay. So counterclockwise. 90 degrees. Rotated. Alright, reflected about a line y equals x. Now, this is something that you want to know for your math knowledge. You should memorize this particular line, y equals x. And you should know that inverse functions switch your x's and your y's. So that's just something just to know about an inverse function. And so, interestingly, whenever you reflect an image about the line y equals x, then what happens is you just switch your x's and your y's. So just a straight swap. So this one is 4, 4. So that one doesn't change, you know, because obviously 4, 4, it's still 4, 4. So that's your B prime right there. And then your C prime, instead of being 0, 5, it's going to be 5, 0. 1, 2, 3, 4, 5. So this is C prime. And then A prime, instead of being 1, 3, it's 3, 1. 1, 2, 3, 1. Okay. And hopefully you can see that that really does look like it's been reflected over this particular line. So just switch your x's and your y's. Isn't that easy? Alright, last problem. Now, let's say you look at this and it has the original, which is solid, and then it has the image. So we have the pre-image that's solid and the image that is dotted. What do you think has been done to the pre-image to create this image? So how did A become where A prime is located? How did B turn out to be where B prime is located? And so you have to come up with whatever that rule is, and that's what you would put here. So this is a good critical thinking problem. So it takes a little while to figure out, like, has it been translated? You know, has the same exact thing been done to every single point? I mean, you can try that. If you go from A to A prime, you know, did I subtract 1 from the x and then add 1 to the y? Well, let's see. Can I do that to the b? Can I just, you know, take 1 away from the b and then move it up 1? You know, that doesn't seem to work, because then the b prime would have been right there, you know, just like the a prime was. So that can't be it. So it's more complicated than that. So it takes a little while to figure out what is going on with this thing. So after you see, you know, maybe one of these or two of these, you start thinking this way a little bit. But what's happening is, right now, this A is, the coordinate is 2, 1, and so the x-coordinate has been cut in half. So instead of it being 2, it's actually only 1, and then the y-coordinate has been doubled. So you can tell the x-coordinate for this is 1, and the y-coordinate, instead of being 1, it's 2. So this particular rule is taking 1/2 of whatever the x is, meaning you're multiplying it by 1/2, and then you're doubling whatever the y-coordinate is. So let's look at these other ones. This one here is currently, or at least it was, -4, -1. If we take half of that, half of the x, then that would make it -2. And then if we multiply the y-coordinate by 2, that would be -2, -2. So boom, there we are. And then same with the b. Currently, or at least originally, the b was 6, -1. So if we multiply the 6 by half, we get 3. So 1, 2, 3. And then if we multiply the y coordinate by 2, that would be -2. So you can see it there. It just takes a little bit of work to come up with it yourself. And voila, we are done. So good luck.